You know that feeling when you're doing an algebra problem and you've run out of space on the page and you're still on problem one? Well, the problem that you were doing was probably a system of three equations. So here's our first and only example. We need to solve for x, y, and z in these equations. Now, for three equations, the best way to solve this is using a method called elimination. Elimination is something you can do with two equations as well, and it will help if you already know how to do that for this video. If you don't already know how to do elimination with two equations, then I have a video on it that you can watch on the card on the screen right now. So you can watch that first and then come back here. So basically, our goal here is to reduce this into two equations with two variables, because we already know how to do that, and that will just make our lives easier. But how do we do that? Well, we can just turn this into multiple two equation problems. So like, for example, let's say that I did elimination on these two equations. And from these two equations, we eliminated the letter y. Then let's say that I did more elimination, but I did it on these two equations. And from there, I also eliminated the letter y. Well, from there, I have just made us two new equations. And both of these equations only have x and z. And then we can use these two equations to eliminate, like, for example, let's say x. And then we're only left with z. So let's go ahead and do that first step that I was talking about. We need to get ourselves two equations that don't have a letter. So we'll use these first two equations first. So remember, elimination is all about adding these two equations together. So first we need to ask ourselves, if we added these together right now, would we eliminate a variable? And in this case, I'm saying we would. We have a plus 2y and a minus 2y. If we add these two together, y will be eliminated from the equation, and that's what we want. So let's just go ahead and add these together right now. 2x plus 3x is 5x, plus 2y minus 2y, that just makes 0. They cancel out, so we'll go ahead and cross those out. And then minus 3z plus z. We lost 3 z's, but then we got 1 back, so we're still down 2 z's. And then 14 minus 5 is 9. So we now have ourselves one equation that doesn't have y in it. So what I'm going to do is I'm going to have the problem over here, and then over here, I'm just going to put some of the new equations that we come up with. So here I'm going to put 5x minus 2z equals 9. So now we need to get ourselves another equation that has no y in it. Well, let's go ahead and use these two equations. So this one's going to be a little trickier because if we add these together immediately, it's not going to get rid of a letter. And just a reminder, this time we want to get rid of y. We can't get rid of some other letter because we need two equations that don't have y in it. So the question that I always ask is, it would be really convenient if the number right here was what number? And I think you would probably say that it would be convenient if this was a 2, because then these would cancel out and we would just add them together. So the question I usually ask next is, what do we have to do to make this number a 2? Well, remember, we don't have a number here, so we just pretend that it's a 1. So how can we make that a 2? Well, if we multiply it by 2, then it will become 2, because 1 times 2 is 2. But remember, in algebra, we have to do something to both sides of the equation. So what we're going to do is we're going to multiply this entire equation by 2. That will make this a 2, but we have to do it to every other part too, so that the equation stays true. So let's go ahead and rewrite these equations, but with our new multiplication. So there we go. Now if we add these two equations together, these y's will cancel out, just like before. So let's go ahead and add them together. So we have 3x minus 8x. That's negative 5x. These cancel out because we have minus 2y plus 2y. Those do the opposite things. And then z plus 6z. 6z's plus another one is 7. And then negative 5 plus negative 14. Lost $5, lost another $14, we've lost 19. So there we go. We've got another equation that doesn't have y in it. So let's go ahead and put it in our little bank up here. So now we have two equations that don't have y in it. And you'll notice here, this actually just looks like a two equations, two unknowns problem. We have two equations and two unknown letters. So we can solve this for one of those letters. So let's go ahead and do that. So now let's go ahead and ask ourselves, if we added these together right now, would we eliminate a variable? In this case, actually, we would. We would eliminate x, because 5x minus 5x, that just does nothing. So these would cancel out. And look at that, we're just down to one letter, and we can solve it for a number. So negative 2z plus 7z, that's just a subtraction problem, flip the other way around. So 7 minus 2 is 5. And 9 minus 19, gain $9, lose $19, you were down $10. And now we're down to a nice one-step algebra problem. What a relief. This is multiplication because there's no sign in between. You assume it's multiplication. So we'll do the opposite, which is division. We will divide both sides by 5. These cancel out, and on this side you're left with z. But on the other side we have 10 divided by 5, which is 2, and we have one negative sign, so the negative sign has to stay. So we now know that z is negative 2, but now we have to solve for the other two letters. So how are we going to solve for another letter? Well, normally, when you do these kinds of problems, you would plug the number back into one of the equations and see what letter you get. But if you plug this number back into one of these equations, you're still going to have an x and a y that you don't know. That's two unknowns, so we can't do that. So instead, what we're going to do is plug this into one of these equations, because if we plug it into z, all that's left is x, and we'll know what x is. So I've put that z is negative 2 over here so we don't forget. And which one do we want to do? I'm going to say, let's do this top one. It really doesn't matter. And what we're going to do is we're going to replace z with negative 2 because they're the same. And we'll see what we get for x. So 5x minus 2 times negative 2 equals 9. Now let's go ahead and clean this up a little bit. 5x, and then we have negative 2 times negative 2. Remember, every minus sign has to stay. And we have two of them, so they actually become positives because two negatives make a positive. So 2 times 2 is 4, so that'll be plus 4, and then equals 9. So now we have a two-step algebra problem. And in this case, we can get rid of the 5 or the 4 to get x by itself. Let's get rid of the 4 first, because the 5 is more attached to the x, and we'd have to divide everything by 5, and we have a bunch of fractions, and no one wants that. So let's get rid of the 4 first by doing the opposite of addition, which is subtraction. We will subtract both sides by 4. These cancel out, and on this side you're just left with 5x. And on the other side, 9 minus 4 is 5. So now we have 5x equals 5. This is multiplication, so we have to do the opposite of multiplication, which is division. So we will divide both sides by 5. These cancel out, and you're left with x. And as I run out of room here, on the other side we have 5 divided by 5, which is 1. So x is equal to 1. So our last letter to figure out is y. How can we figure out y? Well, we have a lot of equations with y in it here, and we couldn't use these before because we didn't know what x was either, so we would have two letters that we don't know. But we know what x is now. So we can replace x with 1 and z with a negative 2, and all we'd be left with is y, and we could solve it for y. So we can choose any of these equations. It really doesn't matter which one you pick, but I feel like I'm going to go for this one because y is already by itself in this part of the equation, and then that's going to save us a step compared to if we did these other ones. So let's go ahead and use this bottom equation. All right, so let's go ahead and replace these letters with what we know. So negative 4 times, and x is 1. We don't know what y is yet. That's what we're trying to solve for. And then 3 times z is negative 2. And that's equal to negative 7. So let's go ahead and clean this up. Negative 4 times 1, anything times 1 is itself, so that's negative 4, plus y. And then 3 times negative 2. 3 times 2 is 6, but the minus sign has to stay. So this is going to become minus 6. And then that's equal to negative 7 still. And now I'm seeing we have two numbers on this left side. So let's just go ahead and combine them. We have negative 4 minus 6. We've lost $4 and then lost another 6. So that's minus 10. You'll notice that it doesn't matter if these two numbers are next to each other. I know they have a y in between them, but we can still add them together. So now we just need to get y by itself. We need to get rid of this minus 10. So we'll do the opposite of minus, which is plus. We will add 10 to both sides. These cancel, and on this side we're just left with plus y, or just y. And on the other side we have negative 7 plus 10, which is just the same as saying 10 minus 7. 10 minus 7 is 3. So y is equal to 3. So there you go. We have our answer here. These are the three letters that we've solved for. But there's one other way to write your answer, and your teacher or professor might want you to write these as like coordinates on a graph or something. In that case, you would write this in parentheses, and you would always go x, y, z. Just like in a graph, you would do x, then y. It's just this time we have a z. So we do x first, which is 1, comma, and then we have y, which is 3, comma, and then we have z, which is minus 2, and then close the parentheses. So our answer is 1, 3, negative 2. There's a car outside. So yeah, that seemed like a lot, But if you break it down into smaller chunks, you'll realize each one is just a two equations problem, which you've probably already learned in this class before. But part of the reason why doing a problem this long can seem daunting is just because it's a really big problem. So you need to make sure that you're breaking it into smaller chunks in your head. Solving three equations with three unknowns is just one of the big mysteries of algebra. The other is domain and range, which you usually go over like right after. So if you want to learn how to find domain and range, then you can watch this video right here. And as always, if you have any questions, just leave it in the comments and I'll be happy to help. Thanks for watching.